In this video, we're going to be examining our properties of exponents. Now remember, the properties of exponents only apply to monomials, monomials meaning one-term polynomials. So if I take a look, the first one we're going to examine is the product rule, also known as the product of powers. And this states that if you multiply like bases, the same base, you are going to add the exponents. So if I have x to the a times x to the b, I'm going to get x to the a plus b. Since I have the same base, I can add a and b together. The same goes over here. If I have 3 squared and 3 to the 4th, since I have the same base, I can add my exponents of 2 and 4 and get 6. Or p squared times p to the 9th would be p to the 11th. So you multiply like bases, you add the exponents. So let's think about the opposite. That's for multiplying. So the opposite of multiplying is dividing. So if I divide like bases, the opposite of adding is subtraction. And so that's our quotient rule. Our quotient rule states that if you are dividing like bases, you subtract the exponents. So if I have x to the a over x to the b, I'm going to get x to the a minus b power. If I have 9 to the 5th over 9 squared, I'm going to get 9 to the 5 minus 2. I would subtract the exponents and get 9 cubed. And you can go through the proof of this means you have 5 9s being multiplied on top and 2 9s in the bottom. And so the 2 on the bottom would cancel with 2 on the top, which is subtracting, and give you 3 left on the top. So if I have b to the 6th over b to the 4th, it's 6 minus 4, b to the 2nd power. So those are our product rule and our quotient rule. Next, we have our negative exponent rule. Now, the negative exponent rule has nothing to do with the sign of the expression being raised to the power. It has to deal with the position of the expression. And so our negative exponent rule, you need to make a note that it deals with position, not sign, not whether it's a positive or negative value. It deals with position. What that means is if you have a negative exponent, that means the power is on the wrong side of a fraction. So move the base to the other side and make the exponents positive. So if I just have x to the negative a, really that's x negative a over 1. Like every expression, if there is no fractions, really over 1. And so that negative tells me that it's on the wrong side of the fraction. So I'm going to move it to the other side and make the exponent positive. The same goes 1 over x to the negative a. That tells me it's on the wrong side of the fraction. So I can move it to the other side, which makes it a positive. So if you have 3 to the negative 5th, that tells you put 1 over 3 to the positive 5th. If you have 1 over b to the negative 7th, then you're going to move the b to the negative 7th to the other side and make the exponent positive to get just b to the positive 7th. So negative exponent's a little tricky for people to understand because negative has nothing to do with the sign. It has to deal with the position of the expression. It means it's on the wrong side, so move it to the other side and make the exponent positive. Next is our power rule. When you are raising the power of an expression to another power, you multiply the exponents. And I like to think of this like the distributive property of exponents. If you have an exponent on the outside of the parentheses, you are going to distribute it and multiply them together. So if I have 3 cubed squared, I'm going to distribute it and get 2 times 3, which is 3 to the 6th. If I have d squared being raised to the 4th power, I'm going to distribute it in, and that will give me d to the 8th. So when you're raising the power of an expression to another power, you multiply the exponents. And we can take this power rule and apply it to the product and quotient rule as well. So if I'm doing the power of a product, you take the power and you distribute it to all the exponents of the bases. So when we're taking the power of a product, distribute the outermost power to the exponents of every base that you see. So x is a base, y is a base. So I'm going to take the a power distributed to the exponents. So that gives me x to the a, y to the a. And I say that word exponents strongly because if I have 2k to the 4th power, the 4 goes to the exponent of the k to give me k to the 4th. but it also goes to the exponent of the 2. And so it gives me 2 to the 4th, which is 16. So 16k to the 4th. If I have ab cubed, I'm going to do a cubed and b cubed. Same idea with power of a quotient. You're going to take the exponent, you're going to distribute the outermost power to the exponents of all the bases in both the numerator and the denominator. So I have xy to the a power. I'm just going to have x to the a over y to the a. So if I have x over y squared, I get x squared over y squared. Little note here is we can also mix in the negative exponent rule. And this is a little bit different if you have a negative exponent with a fraction. What that negative means, again, is things are on the wrong side of the fraction. So what you do is you flip the fraction, so the y is on top, the x is on bottom, and you change the power to a positive. And then do your power rule and distribute it into both the exponents of the numerator and denominator. So if I have a over b to the negative 5th, the first thing I would do is I would flip the fraction to take care of that negative power. So b over a to the 5th, and then distribute the exponent to both the top and the bottom to get b to the 5th over a to the 5th. And the last one is our zero power rule. And our zero power rule states any expression, variable, number, value, etc. to the zero power will always and forever be equal to 1. So x to the 0 is 1, 7 to the 0 is 1, 20 to the 0 power is 1. It will always be equal to 1. So these are properties of exponents, all of our rules. Be confident with these rules before you move on to the videos dealing with our different exercise sets.